The next presentation is special interest to me. For those of you that know me well, you know that I'm a very strong believer in CPT. And when I saw this title of this presentation that Linda suggested initially, I thought, yeah, this is something that we need to talk about. It also moves us to South America, which is also a nice addition. So Paulo, take it away from here with your presentation about optimizing power foundations using CPT. The floor is yours.
Okay, thank you, Joe. I don't know, I have the control right now. Okay, let me check. Okay, and this project in Chile, in the south of Chile, and we make some optimization using in additional soil exploration using CPT test. And the distribution of this presentation is like this in the index. First of all, some explanation why improve the soil operation in the in-situ test, a little explanation for the audience, the project location, the information about the project, additional tests with CPT, liquefaction analysis, optimization of pile depths, and the conclusion. In the first time, it's very important to review why we need to improve the soil operation. This is a graphic for the UK, and obviously, if you saw that if your investment in soil operation is too less, your construction cost is increased. Okay, that is for highway. We analyze in this presentation an overpass. It's like the same. And another information about Dijon from Superpile, and it's very similar from the insurance companies. The most of the problem are related with soil investigation and contraction monitoring. Soil investigation problem in the execution or quality of soil investigation is like 41%. It's a lot. The another problem is the monitoring, QA/QC in this case. And if you review the last one, important is the foundation design. We take the 3 topics in this presentation. It's only a review, very short. What is the kind of test? We have SPT, very popular. CPT, increased the popularity. DMT, PMT, and BST, okay? And obviously, have limitations. It's not possible to use everything in everywhere, and that is depend of the ground size and another thing of the soil. SPT is really popular, but it's have a limitation when you going from the fine soils. And the SPT, it's like this one. You make some count of the blows for the tube, and the tube have it's a Raymond tube, and you introduce the sample here, but the sample is not in the same condition, have a distortion there. For example, another important thing of CPT, that is an example in Concepcion, and the project we study here is very near to Concepcion. And if you have problem with the quality control during the test, give me a second, please. Good. And the quality of the test is very bad. The REF test, it's a test without geotechnical supervision, and the S1 and S2 are SPT tests with supervision, and the results are very different. That is a very important thing when you make some diamond drilling in a sample. It's if you don't have the good quality control for the mud, do you have that kind of problem? And if you need to make some liquefaction analysis, obviously In the first one, you have a lot of problem for liquefaction, and in the second, not really. That is very important. We have another example, more clear than before. If you review the ref test, is this one. You have a lot of things for not have a good math control. And in the second one, obviously, and if you have a good control, the results are very different, really different. That's a very important thing. You need to have a geotechnical engineer makes the control of the diamond drilling and the SPT. Okay, and another important thing in that kind of test is the energy. Sorry, it's wrong word here, but it's energy. It's very nice in Spanish in the another side. We have a control of the energy of a lot of companies, and that is our data for 10 years. Review that, and if you have the test with for manual hammer, the difference between the result of energy, it's like 47 to near to 80. And if you use an automatic hammer, it's possible to have 45 to 115. That is very interesting. I have another presentation for that information. And that idea is only take in account that important things. We make some liquefaction analysis with the energy correction, and if you don't understand the problem, probably your data is wrong. This will be wrong. Okay, for another place, we have TPT, TPTU, and STPTU. That kind of test, it's improved the results, obviously, but you don't have the human intervention in that one, or less human intervention. And in this case, you have 3 sensors, the friction sensor, or pressure sensor, and bottom sensor. And in this case, you have that data for a computer automatically, and it's possible to review the development of the soil and define the kind of soil which is developing. This is a typical real-time data when you make the test. That test is very fast. It's possible to make an exploration for 30 meters in one day if you don't have rock, bedrock, or gravel. And this is the example of soil classification which is developing, and it's very useful and very nice for make the exploration. Okay, this is Chile, far away from the state and another round of the world. Some guys talk about this is the end of the world. I would like to think about this is the beginning of the world. But we are in a different, Chile is really large, and we have a different weather here and different kind of soil. The project is in the medium of Chile. Okay, this is Concepcion. It's in the half of Chile, approximately. And we have a large earthquake here, and in the last biggest one was in 2010, and we have a lot of liquefaction problem near to the failure here. Concepcion is here, is to review, it's a lot of points and figures here from lateral spreading and settlements and liquefaction. Our project is near to Concepcion. Concepcion is here, but Concepcion have a lot of problem with the liquefaction. And the project is like 20 kilometers from Concepcion. And this is an idea from the problem of the earthquake in 2010. moment magnitude of the earthquake was 8.8. It was a lot, a very big one, and the time of the movement is like 3 minutes. It was like 3 minutes. And we have problem with infrastructure for building. If you remember that photo, it was very famous. Unfortunately, we have problem with bridge and harbor. Okay, and we have some problem very near to the project. This is the project. The name of the project is Laboreos. It's the overpass there. And this is the project site. If you see that, we are very near to the coast, and we have a hills there, and in that hills we have a geological chain there, which have sand. It's a basaltic sand, and we have residual soil here. And this is exactly place of the overpass here. And if you see that, we have a hill here, and the coast in that place. I'm sorry, it's the same. Okay, what about the project? Project define a lot of piles in 3 parts, in the center and in the boundaries of the overpass. The number of the pile is like 52, and the length of the piles it's like 20 meters. The pile diameter, really sorry, it's in metric units, and it's 1.5 meters. And when we review the data, that is the overpass before. And in this case, that overpass was built like 2000, 25 years ago. And in this case, this guy have that kind of solution, and the foundation was with micropile. Okay, and the length of micropile is very short. It's like 9 meters. And what about the project? We have 3 in situ tests in the project, 3 borehole here. And the first one is not in the axis of the project. That is very interesting thing, but probably they have problem with to introduce the equipment for make the borehole there. And the result of the soil exploration is this one. We don't know what is the energy of the SPT hammer. We don't know if it's manual or automatic. And we don't know if they have a quality control during the exploration. And when we review that in the borehole 2 and 3, the SPT are very high. But when we review the first one, the SPT is less, like 7 meter, 10 meter, 11 meter, and 16 meter. And that is very confused for us. We have some question about that problem, but probably if we don't have control between the mood here and the result of SPT blow count is reducing, and probably that is a problem in this case. And what about the salt? I'm sorry, it's very teeny that. And we have sand, but in the bottom part we have silty sand, but the color of this one is like green, and in that place the sand color is like black. That is very strange here, and we have some doubt about the situation, but probably they have another soil. It's probably sandstone there. And in another, they have sandstone directly, but not in this one. And just remember that this borehole is not in the axis of the project. And just remember, we was a tremendous earthquake in 2010. That project have 10 years before the earthquake and don't have damage from the earthquake. Possible it's not, probably they don't have problem with liquefaction in this length. We propose to the customer to make some CPT there in the center of the project. And we're going from a GAN equipment there. It's a small one. And we obtain the following results. In this case, the con penetration is very high. It's not really high, but it's more than the SPT. And when review the data and using the equivalent N1 and with 60% of energy, the difference is we have in the first borehole that situation, and right now we have that one. We don't have the same number of blows there, and that is very interesting. Probably they obtain different results for the position of the borehole is different, or they don't have a good quality control there. We make some reject here, but we take some in sandstone, like we expect that. And we make the liquefaction analysis. Obviously, we don't have liquefaction. The number approximately is 30 blow per centimeters for 1 foot. And obviously, we are very far away from that number. Okay. And we introduce more CPT. Obviously, the customer are very happy about this situation, but the length of the pile will be shorter right now. And when we review that information, the first one, we're thinking about, do you really need the piles or not? But sometimes when we work in a public project, it's not very simple to make some radical change in the project. And we try to modify a little bit the project to reduce the length of the pipe. The load of that pile is in static, and load is like 450 metric tons. I don't know what is the comparison between in English unit. I'm sorry. And next, we going to make some test in another pile position. And the results are very similar. And if you don't know some things about the CPT, that is the correlation for relative density. And the relative density are very near to 100. It's really compact sand there. And we touch the sandstone near to 10 meters. Okay. And in the search for in CPT test, we have very similar results. We touch the sandstones like 15 meters, and the relative density is more than 90. Okay, we will start with the structural engineer, is in charge of the design of the overpass, and we talk about the load there. And we divide the stratigraphy with con penetration there. We make some estimation of the pile capacity using the Germany standard. And obviously, it's a lot more than design. And we review the lateral loads too, for it's only an approach. And next, the structural engineer make the design, but we would like to analyze that for obtain an idea from the load. We make an agreement to introduce the pile socketed in the sandstone, like one diameter, 1.5 meters. And the structural engineer modified the design of the piles and introduce a minimum length of the pile. Okay. And in the new chains, the pile are reduced to 12 meters, okay, to 20. And we have the equipment, the drill rings in the job site, and we talked about to make the same pile diameter in this case. And we go there to the job site to review with our CPT data and try to see exactly the sandstone. And in the exactly deep, we see that we obtained that with the drill ring, and it's a sandstone that was very good. And we take some samples, and we go from the lab to try to make some simple compression test. And the correlation was very good. It's a good resistance with there. And that is the conclusion of the project. On the original project, we have bore piles, 52 bore piles. The diameter is 1.5 meters. The deep is 20 meters. And the new project design with the improve the soil exploration campaign, it's the same quantity, but the deep is like 12 meters, 40% of production. The important things to take in account is review the historical information. We saw that the first project was micropiles for 9 meters and not have problem with the liquefaction in 2010. It's mandatory to review the soil exploration quality and thinking about if you use better technology to improve your geotechnical investigation, the results are improved. It's not all the time do you have it's possible to reduce the cost, but you need to know that you reduce the uncertainty. That's the important thing. Okay, and we reduce the time of the project to like 2 months with that modification. Okay. Thank you very much.
Paulo, thank you very much for your presentation, demonstrating that if you do indeed a more elaborate soil investigation, you can reduce your project cost, but also your project duration. And it's always interesting to see. We can show that graph that you started out with, based on research in the UK, quite a bit. If you do more soil investigations, it pays off. But a clear case study like this illustrates it much better.